Okay, so for some reason, I've been leaving H6 completely out. It is in the homework, so we're gonna cover it. It's basically talking about rational and irrational numbers, terminating decimals, non-terminating, terminating decimals, non-terminating decimals, and ones that are not going to be written as fractions. Okay. The Pearson quiz goes live at 1:15, and it's due tomorrow night at 11:59. You get 2 attempts, the best score is kept. Don't forget to try the quiz practice, which nobody's done yet. I'm going to walk you through it today, right after we do these questions, but make sure you try the quiz practice. Because doing a quiz on Pearson is different than doing homework. I have printed out the summary and review, but it's also going to post in the announcements, and I will attach it to the video email that you usually get. Next Tuesday, we review, but we're also going to preview Chapter 9. And next Thursday is a Chapter 8 test. Remember, for the Chapter 8 test, you get a 3x5 card for notes. That's 3x5 inches. No card. Must be handwritten. No photocopies. I'll go into some more explanation about that next week. Tomorrow is the last day to add or drop a class to avoid a W. This is a little bit more at the tail end of 8.5. The slide method that we finished off with. There's a couple more examples that we're going to do when we get into the football hour. First thing you want to do is you want to make a little line right here. And you want to separate those two numbers at the top. You got your 224. You got your 392. You got your OCD because you want to make a good line. There you go. And we're used to making factor trees for one number at a time. What times what makes one number. Now we're just trying to figure out, find a factor, any factor that you know. If you can figure out the greatest common factor, well, it needs to be done already. But find a factor that goes into 224 and 392 even. Just start with something. Any number. We don't want to go 1 because 1's not going to change the numbers. They're both even, you can start with 2. The last 2 digits is 24. That's a 92, so you can divide by 4. 4 goes into 92, 4 goes into 24. 3, 2 plus 2 is 4, 4 plus 4 is 8. It doesn't work. But 4 will work. So if we try 4, I'm going to put a 4 right here. 224 divided by 4 is going to be 56. 224 divided by 4, so you now have 56. And then 392 divided by 4 is going to be 199? No, 198. That's what. Now you can just do that on your calculator, that's fine. You still have 2 numbers. You have a 56 and a 198. What goes into both? What factor would divide both even? We can divide by 2. So now right here we divide by 2. So 56 divided by 2 is going to give us 28. 198 divided by 2 is going to give us 99. So 28 is 4 times 7. So 4 is not going in, or nothing's going, the even is not going to go into the 99, 4 or 2. So the only thing that might work would be a 7. I'm just going to check 7. Well, 7's not going in 99. But already. So we're done. There are no more common factors. The least common multiple, L. The way you find the least common multiple, you're going to make that L shape. So you go this way, down, and you make the L. You use a little turn here, and you multiply all this together. The least common multiple is a 4 times a 2 times a 28 times a 99. Everything along that L path. So let's see, that is going to be, I'm going to do this. 4 times 28, and then times 2 times 99. Do I want to do that? No. Yeah, this is going to be 100 with the total will be 112 times 2 times 99. That's going to be 224 times 99. So that would be 2 minus 224. And that's going to be 6, 7, 1. 22,176. Is that right? Okay. It's a little late in the day. I can't do it in my head, but I can do it on pencil and paper. But 7 times 7, 49. So that's not 196 either. 392 divided by 4. 198. 392 divided by 4. Sorry, 392 divided by. So you divide it by 2 first. Okay, so you divide it by 2, that's okay, that's fine. And then you divide it by 4. So 196 divided by 4. 49. Okay, so where's minus? Let me check minus. And divided by 4, 24 divided by 4 is 56. That's 98. Is that? So let me see. So I divide by 4. So I get 5, that's 20, I get 24, so that's 56, so we're good there.
It's just 98, but 392 divided by 4 is just 98.
It's just 98.
Yeah.
And then when we divide by 2 again, there's 49. So then if we got 49 and 98, okay, hey. I don't know how was your school, teacher school. Thank you. 98, not 190. My brain was doing divided by 2 or something. I don't know. Okay. So everybody's clear on where I made my mistake. Thank you for calling me out on thing. That is important. Because you're gonna have to call a student now. You can't be reserved about it. So I'm not ready to make the L yet. We can't say that L. We're still, the first few days of the relation. Break up my wife on this. But I can always say to my wife, I said it first. So now between a 28 and a 49, what goes into each 48? So we now have a 7. 28 divided by 7 is equal to a 4. And 49 divided by that 7 is going to be a 7. So now 4 and 7 have nothing in common. So now we do the least common multiple, make it that L. Least common multiple is 4 times 2 times 7 times 4 times 7. So I'm going to rearrange this. I'm going to go, that's 4 times 2 times 4, and then times 7 times 7. So I know that this is 8 times 4. This right here is 32 times that right there is 49. So that will be, if I'm doing this without a calculator, so that would be 50 times 2 so 50. Say it again.
1,560.
68. I was going to go 1,600 and then take away that sum. So there's the least common multiple. On your test, let me write this up by hand. I'm looking for those mistakes. If you don't have the right answer, partial credit, you show the one. The greatest common factor. All you do, these are where the factors came from. The factors are straight down that column. So it's 4 times 2 times 7. So it's 8 times 7. The greatest common factor is 56. Using your words, what does it mean that 1,568 is the least common multiple for 224 and 392? What does it mean that that's the least common multiple? What would be another good descriptive word instead of least? There's a synonym. Synonym. Smallest. So 1,568 is the smallest number that set it backward, but you're close. It's not that this number goes into, it's the smallest number that those two numbers divide into. This is the first number, the smallest number, the least common number that these two can divide into. That's the first number they go into either. So if you were to list all the possible multiples of 224 and all the multiples of 392, the first number that they have in common, you wouldn't get to it until you came across 1,568. And then greatest common factor. So instead of least being smallest, greatest would be the biggest. Common, but they haven't, they share in common. factors are what goes into them. So this is the biggest number that can divide those two evenly. So if you had a fraction, let's say you had 392 over 224, the greatest common factor is 56. So 56 times over 56 times, this is 56 times 4, and this is 56 times 40, 49? There's 56 times. And 56 times 40. Yeah, 56 times 49. No. Oh, I'm looking at the 224 is 56 times 4. And the 392 divided by the 56 is going to equal 7. Yeah, 7. So my common factor of 56 reduces, and I'm left with 7 over 4. Greatest common factor. I'm going to come back to that questions 2, 3, 4, 5. Because I want to start the walkthrough on the quiz prep. The Pearson quiz is only on 8.3 and 8.4. The prep has 7 problems in it, but the quiz itself only has 4. And the major thing that I'm concerned about is knowing how to work a quiz instead of a homework, the difference between the two. So there's quiz practice right there. And when you open it up, and this is what the quiz will look like. If you don't remember how to do a quiz, you can always click right here for the tutorial. Otherwise, you're over here and you click on start. You cannot work ahead on the problem. You can't like go to the last question and try to do it. You have to do the first question at a time. So you can take 7 questions. You can do this quiz practice 4 times total. So this is the first attempt. You can save your progress as you go along. Right here, you see the question 2 and 3 all the way to 7. They're all locked. You can't work ahead. So the only one you can work on is question 1. So we get started. Okay. Find the prime factorization of the following number. Write any repeated factors using exponents. So 72. If you make a factor tree, you got 72 is equal to 8 times 9. From now on, let's just remember some 8 is 4 times 2. When you factor in 8, you're always going to get 2 to the third. Because 8 is always going to be 2 to the third power. Now we get 9 is 3 times 3. So they want prime factorization. If you have repeated factors, use exponents. So we have to type in This is 2 to the third times 3 to the second. So if you haven't done this yet with the homework, once again, 2, and then to get the exponent, you use this toolbar. You have to click on it to come up, and then right here is the superscript, so 2 to the third. Now here's the problem with 2 to the third. If you don't move the cursor down from the exponent, and you try to go down to go 3 to the second, if you're still up in the superscript, you're typing 3 up there. So when you want to go times 3 to the second, you need to either click down from there, or you can just use your arrows, and now you know you're down below. Make sure you hit times 3, and then to the second. Now on homeworks, this button says check your answer. It's not saying check your answer, it says next problem. Because it's not going to tell you about right or wrong until you turn it in. Up here is submit quiz. On your homework, it says save. So it's completely different. Here we save the homework. Sorry, here we submit the quiz when we're done. If you accidentally hit submit, it's going to say, are you sure? Does this fix fails? If you hit continue, it's going to turn it in and you only have one question left. So that's not going to be a good score. So we don't we don't want to do that. If you submit now, you won't be able to change your answer. So we want to continue with the quiz. I'm going to go to the next quiz. You're replacing 60 photos in a photo album. You can divide 60 photos so that each page has 2 photos. Sorry, can you? Yes or no? Can you divide 60 photos so you have 5 photos in each album? Can you divide it and so you have 10? So this is just yes or no. Can we put 2 photos on each page using from 60? Yeah. What is this question asking? Can we put 60 photos on a page? They're asking you what? Yeah, is 60 divisible by 2? Can 2 go to 60? Can we put 5 photos on a page? Yeah. Can 5? Now here's where it gets tricky. Look at these jerks. On the first question, yes and then no. But on the part 2, then it goes no and then yes. Okay. Yes, we can put 5 on a page. And then the third one, can we put 10 on a page? Yes. Now, if I'm at home, right about now, the dogs are telling me it's time to eat. Bubbles always comes up at 5 o'clock and stares at me. So Bubbles has got to go get fed. I want to pause the quiz and come back later. That's this button up here, resume later. If you're going to hit resume later, you cannot look at the next question and try to hit it. Because once you see a question, you have to do that problem. So if I want to do resume later, I have to do this now. If I hit next, it's going to make me do that problem. So I want to stop right now, pause it. I hit resume later. And they're always going to make sure, do I want to leave right now? I can't come back, so leave. So I've done 2 questions. So when I come back, I'm going to resume at question number 3. Resume. It's not going to let me change 1 or 2 on that question 3. And if you notice, resume later. If I try to hit this, it's not going to let me do question 3 when I come back, because I've already seen it. Once you see a problem, you have to do that problem. So no, I don't want to do it. Find the prime factorization for 110. So this is just another example. So that's 11 times 10. or 10 times 11, so you have 2 times 5 times 11. Okay, so there's no powers. So I'm gonna get this wrong. 2 times 5 times 11. So I accidentally hit 3. It's not gonna tell me until I turn it in. Prime factorization 513, and then it's very clear, use ascending order. You have to come up with something that goes into 513. Now, we always like to even ones because we can always do 2. But 2's not gonna work. Is there something or some way we can check for another number? What's the rule for 3? If the sum of the digits is divisible by 3. 5 plus 1 is 6. 6 plus 3 is 9. So 3 will work. What else will work if it adds up to 9? 9. If the sum of the digits is 3, you divide by 3. If the sum of the digits is 9, you divide by 9. So 513, and we divide by 9. 9 goes into this 5 times, we get 45. 3, borrow, 11, well, 63. 9 goes into 63, how many times? 7 times. So that's 9 times, it's 63, so it's 0. This is 9 times 7. I'm going to get this one wrong too. Prime factorization. So technically, the right answer would be 3 times 3 times 7. It should be 3 squared times 7. I'm going to put 9 times 7. And I go to the next way. We are packaging 285 cookies for a bake sale. Packages can have 2, 5, or 10 cookies. Will you package all 285 cookies and each package has 50 cookies? You see the question just like this. Can we package all 285 cookies if we have each package in 2 cookies? No, 2 can't go into 285, not even. That's a no. How about 5 cookies per package? That goes in evens, that's a yes. What about 10 cookies? 285 cookies and 10 cookies per package. Nope, because it doesn't end in a 0. That's a no. Uh-oh, the dreaded leap years. Leap years are divisible by 4. However, if the year ends in 2 zeros, it must be divisible by 400 in order to be a leap year. Determine whether the years 1999, 2332, and 1200 are leap years. Must be divisible by 4. So 1999, that leap year? Is it divisible by 4? No, it's off. What about 2332? The rule for divisibility on a 4, we'll check the last 2 digits.
Yes.
So 32, it works. So that's a yes. And then 1200. And then you go back to the definition. If it is divisible by 4, however, if the year ends in 2 zeros, it must be divisible by 400 in order to be a leap year. So it ends in 2 zeros, but does 400 go in? Yes. 400 goes into it, so this. And this is the last question, the prime factorization of 84. 84 is what times what? About 4 times and 1, 2, and 2, and 3 times 7. So 2 squared times 3 times 7. And it says you must use ascending order. So 2 second 3 times 7. Always make sure, look at your answer before you hit the next question. Now that's the last question, we hit submit. Turn it in. Are you ready to submit? Yes. I got a 71.43. So if that's my first attempt, I come over here, what did I do wrong? So I hit review. And it's over here, it shows me which questions I got wrong. I can expand that just a little bit. Question number 3. All right, that's incorrect. The correct answer was 2 times 5 times 11. My answer is, remember, like punching up 3 instead of a 5. So I wasn't paying attention to what I was punching. Okay. The next one I got wrong was number 4. Prime factorization. The correct answer is 3 to the 3rd times 19. Wow, I was way off. I typed in 9 times 7. So when I divided by 9, I really got that mistake. So I didn't do that one at all correctly. But now I know which ones I need to pay attention when I do the same thing. And that's why you have 4 attempts at the quiz prep before you actually take the quiz. And so the actual quiz will go live at 1:15 and that was tomorrow night. Come on back, since I went a little longer, come on back at 12:05.